y is the next vertex having minimum d value. Is that clear? Okay, so now you have this table, that is point number 3. Redraw the table first. V dot d, v dot pi. Okay, what are the vertices? S, T, X, y, Z, Y. It is 0 nil, it is 10s, it is infinity nil, it is infinity nil, it is 5 and s. Okay, so once the part is over, s is cancelled, it will not come again. Okay, then among this 4, now your turn is to explore y. Okay, y will now be in the list of s. Now your set was consisting of only s. Now s equals to s union y. That means s comma y is in the set. Okay, that means you are now exploring y. Exploring y means identify the adjacent of y from the remaining. From the remaining means from t, x and y. You are not supposed to consider source vertex again, because once the vertex completes its execution, it will not come to the picture again. Now you are exploring y. Once y completes its execution, you have the remaining 3 vertices. Y will not come into the picture. After completion of the task of y, among these 3, based on the selection criteria, you will take any one of these 3 and explore it. Once this completes its execution, it will be in the resulting set and take the remaining. Okay, so who are the adjacent of y? Adjacent of y is t, adjacent of y is x, adjacent of y is z also. Even though s was the adjacent of y, you cannot consider s because s completes its execution. So you have 3 vertex, one is t, one is x, another one is y. All 3 are adjacent of y because you can travel from y to t, you can travel from y to x, and you can travel from y to z. Fine. So now you have this table, that is point number 3. I am writing again this one, that is v dot d, v dot pi, s, t, x, y and z, or x, z and y, any order you can write. So it is 0 nil, it completes its execution. This is 10s, this is infinity nil, this is infinity nil, and this is 5s. This is complete. This is, now you are exploring it. So take the graph. Okay, and what is the d, what are the adjacent? One is t, second one is x, and third one is z. What is their current d value? Current d value of t is 10, current d value of x is infinity, current d value of z is also infinity. So you have to now apply the relaxation process between y and z, between y and x, and between y and t. First apply y and t. So t dot d is 10, y dot d is 5, w of y to t, w of y to t, y to t, this is 3 unit. So t dot d is greater than y dot d plus w of yt. You have to check whether it satisfies or not. It is 10, it is 5, it is 3, yes, it is 8. Okay, so the new value, d value of t is 8, and t dot pi is y, because due to y you can reduce the cost. So if you modify the table, or if you want to redraw the table at point number 4 or step number 4, whatever you call it, so it is v dot d, it is v dot pi, s complete, t, x, y and z. It is 0 nil, it completes. It was 10, now the new cost is 8. That means shortest path estimate is 8. And it was s, now new one is y. Okay, so now apply it for x. Okay, x dot d is infinity, y dot d is 5, w of y to x, take the graph, y to x, the distance is 9, y to x, the distance is 9. Okay, so x dot d is greater than y dot d plus w of yx. This is infinity, this is 5 plus w of yx means 9, so it is 14. So definitely it satisfies the new shortest path estimate for the vertex x is 14, and x dot pi is definitely y. So you can modify the table. It is right here. So what will be the new shortest path estimate? It is 14, and it was nil, now it is y. Okay, and what about y? It was 5 and s, and you are exploring it now. So the remaining one is z. So z dot d, presently it is infinity. Y dot d, because you are exploring y dot d is 5. Okay, w of y to z, take the graph, y to z, edge weight, that is 2. Okay, fine. So z dot d is greater than y dot d plus w of yz. It is infinity, greater than 5 plus 2, 7. So definitely satisfies. So z dot d is 7 and z dot pi is y. Okay, it was earlier infinity and nil, it is now being replaced as 7 and y. Okay, so now from this table, this is done, this is done. Okay, which 3 vertices are the remaining vertex? So the remaining vertex are t, remaining vertex are x, remaining vertex is z. What is the d value? Current d value of t is 8. What is the d value of x? Current d value is 14. What is the d value of z? It is 7. Which one is the minimum? 7. So now you have to explore z. And what are the remaining vertices including z? The remaining vertices are t, x and z. Why not I am considering s and y? Because s completes its execution, y finishes its execution, so you cannot call s and y back. So among these 3, identify the vertex having minimum d value. Okay, here it is for z. So now you have to explore z. Fine. So the table is now this one, v dot d, v dot pi. Okay, and it is s, it is t, it was x, it was z, it was y, it was 0 and nil. It is done. It was updated as 8 and y, it was updated at 14 and y, it was updated as 7 and y, it was 5 and s. It is done. So now your task is to explore z. Okay, take the graph and go for the further process. Z, who are the adjacent of z? From z you can move to x, From Z you can move to S. You cannot go back to S because S is complete. So only the vertex X is the adjacent of Z. Right? So only the vertex X is the adjacent of Z. Okay? And you are now exploring Z. You are now exploring Z. So keep the graph here. You are now exploring Z. Why you are exploring Z? Because Z has the minimum D value. Okay. So what is Z dot D? It is 7. Now, who are the adjacent of Z? From the graph, one is S, but S is cancelled. Another one is X. So identify its current D value. X dot D, it is 14. Okay. So apply relaxation from Z to X if possible. So the formula Z to X means X dot D is greater than Z dot D plus W of ZX. I do not know whether it is possible or not, but you have to check it. What is X dot D? 14 is greater than. What is Z dot D? 7 plus. What is W of ZX? That is the edge weight in between Z to X. What is it? It is 6. What is the value? 13. Yes, 14 is greater than 13. So what will be the new D value for X? It is 13. And what will be the pi value of X? Because as the cost is reduced due to the presence of Z, so pi will be Z. Okay. So I am modifying here. So the new value of X is 13. New value of X is 13. And the new predecessor is Z. Okay. So the modified table is V dot D, V dot pi, okay, S 0 nil, then T 8 Y, then X, now it is 13 Z, Z 7 Y, Y 5 and S. Among these three, S complete, Y was complete, now Z is complete. Okay. What are the remaining two vertices? The remaining two vertices are T and X. Okay. Remaining two vertices are T and X. What is the D value of T? D value of T was 8. What is the D value of X? D value of X is 13. Which one is the minimum? Minimum one is for T. So now you have to explore T. Explore T means you have to identify its adjacent, that is adjacent of T, and apply the relaxation from T to that adjacent if possible. So the first adjacent is X, second adjacent was Y, but you cannot consider Y because Y completes its execution, because I told once the vertex completes its execution you cannot take it back. So only the vertex X is the adjacent of T. Okay, so write D value of X, which is 13, D value of T, which is 8, W of T to X from the graph, W of T to X is 1 unit. This is 1. So the formula X dot D, that means where you are going, is greater than T dot D, that means X dot D, that means to the target one, that means where you are going, and T dot D means from where you are moving, and to that means it is a destination, that means a T to X basically. From where you are moving, that is T, where you to move, that is X. X dot D is greater than T dot D plus W of Tx. See whether this satisfies or not. 13 is greater than 8 plus 1, yes, 9. So X dot D is reduced from 13 to 9, and X dot pi is definitely T, because due to T you are reducing it. Okay, so what will be the new value of X? It was 13, now it was reduced to 9. It was due to Z. Now the cost is reduced due to T. Okay. So what will be the table? Table is now V dot D, V dot pi, S, that is T, X, Z and Y. It is 0 and nil. It is updated as 8 and Y. It was reduced to 9 and T. Z was 7 and Y, and it was 5 and S. Okay, fine. So S complete, next Y completes, then Z completes, now T completes, remaining is X. X by default complete. Okay, so all are finished. Fine. Then the final set S, first hold S, then X plus Y, then it was the term for Z, then T, and finally then X. Okay, so all vertices are covered. Fine. So this is your final table. Okay, now there is a very simple approach. You will find this is very interesting. Let us take the graph here and let us keep the table, write the table again. So I am writing now the final table. Final table is now written as final table. That is, final table means D value and pi value, V dot D, V dot pi. Okay, S, T, then that was X, then Z, last one was Y. It is finally 0 nil. What is final T? 8 and Y. What is X? 9 and T. What is Z? 7 and Y. What is Y? 5 and S. Okay, so this is the final table after all steps are over, and this is the graph. Okay, this is the graph and this is the final table. Okay, once the process completes its execution, then you will get the D value, that is shortest path estimate for all the vertices. Okay, which one is the source? S is the source. What is the shortest path estimate for S? It is 0, because you are moving from the source. Okay, and what is the predecessor? As the D value is 0, so definitely it has no predecessor. That's why it is nil. What is the D value of T? That is 8. For X it is 9. For Y it is 7. For Y it is 5. For Z it is 7. And you are getting the predecessors here. So now the beauty of the algorithm is, take any two vertex. One of this must be source. And suppose you have decided to move from source to Z. It is your problem. So what is the shortest distance from source to Z? This is 7. Okay, so the final D value of the vertex Z is the shortest distance from S to Z. Then your question will be, sir, what will be the path from S to Z? So write S, write Z. Okay. Okay. What is the predecessor of Z? Y. What is the predecessor of Y? S itself. Okay. Take the graph. S to Y. What is the distance? 5. Y to Z. What is the distance? Y to Z. Y to Z. Yes. What is the distance? 2. What is the total distance? 7. Very simple. So let us take another one. S to suppose X. What is the D value of X? Final D value? 9. So the shortest distance is 9. So what is the path? Write X. S, write X. Okay, what is the pi field or predecessor of x? It is t. Fine. Move on t. What is the predecessor of t? Y. Move on y. What is the predecessor of y? S. So move on until you find s. What is the distance from s to y? Go back to graph. S to y, it is 5. What is y to t? Y to t, it is 3. What is t to x? T to x, it was 1. What is the total weight? 5 plus 3, 8 plus 1, 9. Okay, so this is about Dijkstra algorithm. Thank you.